All right. Hi, guys. Thanks for tuning in, whether you're watching this later or I guess if you're in the chat. I don't think anyone's in the chat yet. So, as you can see from the title, I'm going to go over the free paper that Revision Village offers. I already went through paper 1, and I think today I'm going through paper 2, HL level. And gonna be honest, I'm a little tired today, so no guarantees that my math is gonna be super solid, but that's okay. I'm sure my thinking process and methodology is still gonna be okay. Oh man, okay. But yeah, I was supposed to do this on Tuesday, but again, my kids had a big test, so I just kind of went over some questions with them. And I know some of you are maybe wondering, you know, am I going to go through Revision Village's like exclusive content? And unfortunately, I am not. I do have an account, but you know, that was paid for by my department, and I'm not going to use that for personal use, which is what streaming is. However, everything I've done so far on Revision Village has been free, so is this one. Anyways, okay, paper 2, we got calculator. What does it say? I have a quadrilateral, ABC, D, and then we can just draw some sort of random four-sided shape. And then let's just label these A, B, C, D. That's 9. This is 12. This is 11. And this is 8.5. So obviously not to scale. Okay, what else do we know? We know that angle ABC is 90 degrees, so this is 90 right here. Thus, we need to find angle ADC over here. Okay, so this is pretty easy, right? We can just draw a line connecting A to C. And then we can essentially use cosine law with triangle ABC, figure out this line. And then we can then do a little bit more, and then eventually we do sine law, cosine law to figure out this angle, cosine law. So that's the plan. We got to figure out this line first. So easy peasy, cosine law. I'm going to call this, I don't know, like x, for example. So according to cosine law, x squared is going to be 9 squared. Actually, I don't even need cosine law. This is 90 degrees. What am I talking about? Let's just use Pythagoras. See, this is what I mean. I'm a little tired today. So x squared is 9 squared plus 12 squared. So again, this is a calculator thing, but you do Pythagoras, you can find out what x is. But you don't necessarily need it. I'm pretty sure x is 15. Because essentially this is a 3, 4, 5 triangle. But, you know, we just multiply all 3 sides by a factor of 3. So 5 times 3 is 15. Okay, and then we will have to use cosine law on triangle ACD to find out angle D, just because, well, we don't know if it's necessarily a right triangle. Again, all of this is just in calculator, right? So cosine of angle D is 8.5 squared plus 11 squared minus 15 squared divided by 2 times 8.5 times 11. So pretty straightforward, and then of course we'll take the inverse cosine because we do want angle D. I guess technically it's ADC or something. So we'll take the inverse cosine of all of this stuff. Okay, let me load up my calculator. And clear everything out. And make sure that I'm in degree mode because we're working with degrees. Okay, so inverse cosine of all of this. 8.5 squared plus 11 squared minus 15 squared divided by 2 times 8.5 times 11. Close the bracket, close the bracket. I think that's all the brackets I need. And tell me the answer. 99.8 degrees. So there we go. And I think that's the to the nearest degree. So 100 degrees. Hi, I'm not 5 a.m. How are you doing? Yeah, easy peasy. Okay, question number 2. We have the velocity function of a particle. Find out when the particle is at rest. So again, we need to find out when the velocity is 0. And we can do that using a graphing calculator. So just plug in your function and then find out where you have your zeros, literally. And then make sure you fix your window. They do specify this is from 0 to 6, so I'm just going to put 0. Well, actually, I'm going to put -1 to 7. And then for the y values, I don't know. I'm going to, if you're not sure, I like to default to -10 to 10. But we can graph this. And then there you go. So this is my velocity function, and you can clearly see that this is where it's going to be 0. So we can press second function and calculate zeros. And then according to the TI, you need to indicate a left bound and a right boundary, and then make a guess. But you should get this. So the particle has a velocity of 0. In other words, it's at rest at 3.92 seconds. Okay, find the acceleration of the particle when the velocity is 3. So this is easy enough, right? Acceleration is the derivative of the velocity. So the acceleration at 3 is just the derivative at 3. And again, this is all just calculator work. Super exciting. I'm going to calculate the derivative dy dx. And then you can type in the value. You can choose a cursor, but obviously that's not super great. You just literally type in 3. So there you go. The derivative is 1.37. And then this is meters per second squared. Thus, find the total distance traveled by the particle. So I mentioned this before, but of course, the total distance, well, let me just explain it again for those that, didn't watch the other stream. But this is my velocity function. And then notice in this section here, your velocity is negative. So in terms of orientation, you could say like you're moving towards the left. And then afterwards it stops because you have to stop before you start moving towards the right because this is positive velocity. So if we were to find the distance, well, this is an integration. But the area between the graph and the x-axis, they have different signs. This is going to be a negative area. And that makes sense because you're moving towards the left. Your velocity is negative. So your distance is towards the left. And then after you stop and then you start heading to the right, the area is positive because the distance you've moved is now towards the right. So if you were to do an integral from 0 to 6, which is the time, right? From 0 to 6 of the velocity. This is not total distance. What this is its displacement. It's where you are with respect to where you started. So obviously you should be adding these two values together, assuming that this one you turn it positive because, you know, for example, let's say you move 3 meters to the left and then you move 3 meters to the right. Well, if you do that integral, you'll get 0 because you basically end up where you started. But that's not the total distance you traveled. You traveled a total of 6 meters. It's just 3 were to the left and 3 were to the right. So what you can do is, there's a couple of ways that you can do this. You can split this up into 2 separate integrals. Split it up into the negative parts and the positive parts, which is why they kind of asked you for this, part A, 3.92. So that's the negative part. And then this is the positive part. And then we need to make this negative part positive, so you multiply by a negative, and then you add them together. So this is a way that you can do it. It's kind of cumbersome and a little annoying. Another way that you can do this is you can do the integral from 0 to 6 of the absolute value. Because the absolute value just means that you're going to vertically reflect any negative portions of your graph. Let's see, can I use a new color? Purple. So this negative part gets reflected upwards, and then anything that was positive stays positive. And obviously, this area is exactly the same as this area in terms of like magnitude. Like if this was 3 meters to the left, this is still 3 meters. Now it's just to the right, I guess, if you wanted to give it a direction. But we don't have to split up our integral if we take the absolute value, because both areas will be positive. So maybe this is something you want to look into doing, and it's not too bad to do. So what we can do is we can go back to here, and then I can insert the absolute value. This is under your math options. Oh, and then you can type it in here. So I guess I'll just retype it in. And then I'll get rid of this stuff. Oops. Sure. Okay. So here it is. I couldn't get rid of this exponent, so I just put 1 there. But notice that when we graph it, now it's just the absolute value version. And when I calculate the integral from 0 to 6, hopefully this works. Oh, I didn't do integral. Choose the integral and then pick the lower limit as 0, the upper limit as 6. And then there you go. So the total distance you actually traveled is 15.4 meters. And again, just to emphasize, I'm going to show you the integral of it without the absolute value. So you see it says negative 3.77. So that means that you've moved to the left and then you move to the right. And then compared to where you started at the very beginning at time equals 0, you're still about 4 meters to the left. But yeah, so just be careful. It's pretty obvious though, they do say total distance, but it is something to watch out for. All right, compound interest question. So on Gary's 50th birthday, he invests in an account, annual interest of 5%, compounded monthly. And then the money's gonna follow a geometric sequence, and then we need to find out what the common ratio is. I went through this question, so I'm gonna quickly go through it again. But basically, so the first term is the beginning, right? When time equals 0. And he invests $P. And we need to find out the next term in the sequence, and then we can find out what the common ratio is. So the next term is after 1 year. And we do have a formula for that, right? The future value is P, the initial investment, times 1 plus 5 over 100. And then this one is compounded monthly, so by 12 to the power of 12 times 1, because it's been 1 year. So all of this is just formula book stuff, right? Okay, so here's my first term. Here's my second term. And I know that the common ratio is just the quotient of 2 consecutive terms. So I'm going to take u2 and I'm going to divide by u1. Now look at what happens when I divide the 2. This p is just going to cancel out with this p. So the common ratio is just this. Which makes sense because this is the yearly, this is what you multiply by every year. So then that's literally the ratio. Okay, so I'm sure they want this as an actual decimal. So let's just evaluate everything. And then there you go, 1.05, which looks familiar. So I think I continued to do this question correctly. Okay, so then afterwards, Gary is no longer going to add or take away money from the account. Find the age when the amount will be doubled. So basically, we want the future value to be 2 times p. And then if I'm using the geometric whatever, then t is how many years need to pass so that you get double the p's. And then of course your p's cancel out, which is why you don't even need to know how much he invests in the first place. And essentially we are solving this equation. And I think I solved this through graphing last time, so let's use logarithms and solve this algebraically. So converting this into logarithmic form, this is log of 1.05, well, base 1.05 of 2 will equal t. And then to evaluate this, I have a graphing calculator that can do separate bases. So here I go, I can put this in 1.05 and put in 2. And then I get 14.2. And if you're working with an older calculator that can't choose your base, then you'll have to do a change of base. So you can either use natural log or log. These are generally the ones that are found in most scientific calculators. And that's easy to do. And apply the formula. And then you can put this in a calculator. Either way, you get 14.2 years. So after 14.2 years, this person will double their money. And then let me just double check that's what the question wants. We want to find his age. So on his 50th birthday is when he started investing, and then he's going to get it 14.2 years later. So when he's 64. Yeah, that sounds about right. Seems like today's gonna be chill stream, which is nice. Alright, let's see what this says. It is given that 3 in 10 men take less than 220 minutes to run a marathon. It's also known that 1 in 5 men take more than 274 minutes. Okay, and then we know that the time it takes in minutes for the men to run the marathon is a normal distribution, and then we need to find the mean and standard deviation. Okay, so whenever you have a normal distribution, I recommend that you visualize it. So it takes 3 in 10 men to finish less than 220 minutes. So this is the probability here. And then at the same time, it takes, well, we know about 1 in 5 men take more than 274 minutes. So the probability of finishing more than that is 1 in 5. And we want to find the mean and standard deviation, which are things that we don't know. And if you don't know these, then that means that we need to do a standard normal distribution. So we'll need to convert each one of these boundaries into a z-score. So this z-score is 220 minus the mean, which we don't know yet, divided by the standard deviation. This one as well, following the same pattern. I guess I'll call this Z1, Z2. This is 274 divided by standard deviation. Okay, when we standardize though, the probability stays the same. But the good thing is when we do standardize, we know that the mean is 0 and the standard distribution is 1. So what I can do is I can find out what the z-score is using the probability and inverse normals. So that's what I'm going to do. I'm going to inverse normal so I can get the z-scores calculated out. So quit. And then I go to second vars, which is my distributions. And then option 3 is inverse normals. Okay. So the first area is 3 over 10. You can write it as a fraction. I'm pretty sure the calculator can handle this. And then you have your mean and standard distribution. So the z-score is negative 0.524. So now we have this nice equation. And we're going to do the exact same thing. Now, one thing to note is that inverse normal is an upper boundary. It requires an upper boundary. Now, we do not have an upper boundary here. My z-score is a lower boundary. So I'm going to need to change this to a upper boundary probability. And that's easy enough to do. 274 is the upper boundary of this probability right here. All of that stuff. Here, let me color it. So all of this stuff. And we know that that's just the complement. So this has a probability of 4 out of 5. So I'm going to use inverse normal on this. So 4 out of 5. Same thing. And then I get 0.842. Alrighty, so now we have two equations that each contain two variables. So we just solve this system. So next up, solve the system. There's plenty of ways to do this. We do have a graphing calculator, so the easiest thing would be to graph these. What I'm going to do though is I'm going to, let's call this equation 1 and then this one equation 2. I'm going to rewrite equation 1 isolating for a variable. So the easiest one to isolate for is my standard deviation. And essentially, I can just graph this as x and y and find their intersection. And I'm sure your graphing calculator has a fancy way to solve systems, not through graphing, but I don't know. There's too many functions, and I don't want to bother remembering them all. So I'm just going to graph them and find their intersection, because that also always works. So let's see, 274 minus x divided by 0.842. Okay, and then obviously you should keep in mind, you know, this is x and y, but our variables are mu and sigma. So, you know, just remember which variable represents which variable. Oh, this is not going to show up on my graph at all. So let me change my window. I need to fix my window. So this is the downside, obviously, of doing this by graphing. You have to deal with windows. And you know what? I'm cheating because, of course, I'm on a computer, so I have superior ways to graph things. So let's see, y equals 220 minus x over negative 0.524. And then y equals the other one, 274 minus x divided by 0.8 something. .842. And then I can just zoom out, and then there it is. Oh, I was changing the wrong window, that's why. I should have had my x's in the 200s. But anyways, here it is. So again, my x variable represents mu, my y variable represents sigma. So I have a mean of 240.7. And a standard deviation of 39.5. And I think that's it. So pretty standard question for finding, you know, two unknowns. I guess it's a chill day for you guys too, because no one's asking for any math help. Ooh, okay, this one's fun. We have students that need to be arranged into a lab, and then the lab is set out in 2 rows of 5. And then you need to find the number of ways students may be arranged in the lab. So there are 10 students, and then if there's no particular restrictions, then the number of ways that they can be put in the lab is 10 factorial. You can put 10 students in the first desk, and then after one person sits down, there's 9 people that can sit in the second desk, 8 people, 7 people, all the way to the last person. And then you just multiply all your choices together. So 10 factorial. Okay, then Hugo and Leo talk too much. So find the number of ways the students may be arranged if Hugo and Leo must sit so that one is directly behind the other. So essentially, a pair of desks is always taken. And then we need to seat the others. And my combinatorics is kind of rusty, especially for HL level, but this is how I'm thinking of it. And it might not be true. I'm going to check the answer right away. I need to seat 8 students. Well, actually, let's first seat these guys. So there are 5 different pairs, and then we need to choose one of them for Hugo and whatever to sit. So in other words, that's 5C1, which is just 5. There's 5 choices. Then this is selecting which desks they sit in. Then we need to seat the other 8 students. So this is going to get multiplied by 8 factorial. Also, you need to consider who's sitting in front. Is it Hugo in front or Leo? So each one of these combinations has 2 options depending on who sits in the front. So we also need to multiply this by 2. So hopefully this is correct. But like I said, I'm a little tired today, and combinatorics it can get kind of complicated sometimes. Okay, so 2 times 5 times 8 factorial. So 403,200. So hopefully I'm right. That's question B. Nice. 403,200. Quite happy with myself actually with that one. Okay, let's see. Find the number of ways students may be arranged if Hugo and Leo must not sit next to each other in the same row. Okay. So when you want to find out how things are not going to happen, then what you should do is you should find out how many ways they are going to happen and then subtract them from the total amount of ways. So first, let's find out how many ways Hugo and whatever can sit together in the same row. So essentially, we can consider them as one person. Oh, Hugo and Leo, whatever. Hugo and Hugo. And because they sit together in one row, and you consider them one person, then essentially one of the rows has 4 choices. So in other words, if Hugo and Hugo sit together, then the amount of ways that they can sit together in a row plus everyone else in that row is so again, Hugo, Hugo, and then we consider them as one person, so then there's 9 people. And then Hugo and Hugo sit together. And then from there, we have the other 8 people that can be seated. So 8, 7, 6. This one's going to be a little confusing. Okay, and then, of course, this is assuming that they sit in the first 2 desks. And of course, they can sit anywhere. So they could have sat like this. So now they are in the second and third desk. So what we need to do is we need to take this and then multiply by 4, because there's 4 different places that Hugo and Hugo can sit together in the first row. And then we need to consider that we also need to rearrange everyone in the back row, for example. So those are the other, 5 people? So then this is just multiplied by 5 factorial. Okay, so that is the front row. Then we need to multiply this by 2 again, because Hugo and Hugo can sit in the back row. So then this is doubled. And then I think you need to multiply by another 2, because again, Hugo and Hugo can switch places. We don't know who sits to the left or to the right of one another. So this is how many ways they can sit together, and then how many ways they cannot sit together is all the ways that everyone can sit together subtracted from this. Well, taking this away from that. And again, I'm not entirely sure if this is the right way to go through it. I'm sure there's a more elegant way, but we'll see. So I'm going to go to 10 factorial. And then I'm going to subtract a bunch of things. So 2 times 2 times 4 is 16. And I'm going to multiply this by 8 times 7 times 6. And also by 5 factorial. I guess this is just 8 factorial, but oh well. And I really hope that this is right. So 283680. 29836670. Was that what I just said? Two 9836680. And let's see. I have a feeling this one's wrong. Oh, 293860. I'm right. But I feel like their explanation is going to be a little bit more elegant. Okay. There are 8 times 2. There's 16 ways that they can sit next to each other. Then the rest of the students need to be arranged 8 factorial ways. So then you multiply those together, and then you do this. Okay. How do they get 8 times 2? Not sure. But, oh well. Maybe less efficient, but I still did it. So I'm going to move on. Oh, this one's so annoying. So we need to perform a linear regression, and then line 1 is the regression of x on y. But first, let's add these to our lists. So let me clear these lists out. And then list 1, I'm just going to say is the x's. So that's 5, 6, 9, 12, 12, 16, 20, and 25. And then my y values are 6, 8, 12. Whoa. Uh-oh. Six, 8, 12, 13, 15, 17, 24, and 22. Oops. 22. Okay, and then we go back to stat, and then we're going to do linear regression. And then my x list is actually the y list. So I'm going to say that this is list 2, and then the other one is list 1. So my a value is 1.05. My b value is negative 2.16. Okay, and then we do a regression of y on x, so the other way around. And then the two lines will intersect, and they're going to intersect at PQ. And we mentioned this before, but essentially the regression of both lines have to go through the average of both lists. So what I can do is I can just calculate those. Because I have two lists, I can do two variable stats. And I guess to avoid confusion, I'm going to make the x list the actual x's and the y list the y's. So here's my average x value, so 13.1. And then 14.6. Alrighty, and then let's see. Andrew's injury didn't allow him to play in the first game, but he played and scored 10 points in the second game. Use an appropriate regression equation to estimate the number of points he would have scored in the first game. Round your answer to the nearest point. Okay, so we know how much he scored on the second game. He scored 10. And we want to find out how much he scored in the first game. So essentially, we just plug in 10 as our y value to get the x value. Okay, so following the formula, 1.05 times 10. And then subtract 2.16. And then round your answer to the nearest point, so 8 points. Alrighty. Let's see what this is about. This does not look good. So we have a diagram as so. And then we have a rope here. We know that this is 6, and we know the area of the field outside the enclosure that the goat can graze is... Okay, I need to actually read this. Hello, squishing. End of the rope attached at point D, and the other is... Okay, so then there's a goat here, I guess. Okay, given that the rope is 6 meters long and the area of field outside the enclosure that the goat is able to graze is 74.2 meters, find the value of A. What the hell? Okay. So this goat can walk in a circle because it's attached to a rope. And he can eat all of this stuff except for the stuff in the fence because he's a goat and he can't get in the fence. And so we need to find the value of this angle. Okay, well, let's start with some basics. The area of the circle is pi r squared, so it's 36 pi. And then can I do some geometry stuff? See, I'm hesitant to just say that this leash exactly lines up. It doesn't even line up with the actual picture, but like, pretend it was like this. Because if that's so, then the question's easy, because then you just subtract the area of the triangle. And we can just solve for alpha that way. Because we know that this is 74. But I don't think that's the case. Because I think the enclosure actually sticks out a little bit. All right. I'm completely stuck. So I can draw that there. Okay, what if I draw this here? Then I know that this is 4 meters because this needs to be 6. Oh, hello, Jeremiah. And then I know that this is 2 pi over 3. So then I can eventually find out using cosine law what this is going to be. But what does that even let me do? I don't think it lets me do anything. Alright. Time to cheat. Wait a minute. Okay. I completely thought that the leash could go through the fence, which obviously doesn't make sense. It's been a long day. I said as a disclaimer that today wouldn't be super great. Okay, so look at this goat. It can essentially go here. No, it's fine. And then basically if it wants to continue walking this way around the fence, the leash is gonna get caught on this corner. So the radius changes, and then now you have a second part of a circle. Oh. Hello, Bobbert P. And then again, once you reach this part here, if you wanted to continue grazing and going this way, you're going to get caught on this corner. So the 4 meter leash now also becomes a 1 meter leash. And then it'll rotate around here. So let me just change the color so that this makes more sense. Okay. This is actually a question that you guys can do, Vincent, because this is just a very advanced SL level question. All right, so the area of these 3 parts is 74 meters squared. And these are all essentially just areas of sectors. This first sector is half a circle of a radius of 6. So this is 36 pi. Then we can find the area of this sector. And this has an angle of 2 over 3 pi. Because I know this is pi over 3. And I know that the radius of this sector is 4. Oh, 36 pi divided by 2, because it's half the circle. So 18. Yeah, I didn't see it. So then the area of this sector here is 1 something. 1/2 times the angle times the radius squared. So what is this going to be? 16 pi over 3. And then likewise, the very last section right here is going to be some amount that I'm not entirely sure how we can figure that out, because I don't know what angle this is off the top of my head. Oh, okay. And then this is where it comes into play that I can finally find out this angle here. Because let me just make some space here. I like this question. It was just difficult is all. So we know that the 3 internal angles of the triangle, this is 6. This is an unrealistic 6 marks. So I'm going to call this angle right here beta. So I know that these 3 angles will add up to 180 degrees, which is pi in terms of radians. And then at the same time, the angle of my sector, this angle, that angle is the supplement angle, because the sector angle and beta need to make 180 together. So that angle is pi times beta. Of course, we can write beta in terms of alpha. So this is beta. And then we can make a quick substitution. And then again, this is the sector angle. The pi's cancel out, and then you're left with positive beta plus pi over 3. So here's my sector angle. So the area of this sector is going to be 1/2 alpha plus pi over 3 times the radius squared, which is just 1 squared. So in other words, 1/2 of alpha plus pi over 6. Excellent. Okay, and then I know what all 3 of these areas add to together, because it tells you that it's a total of 74 meters. So then we're basically done. Man, that was tough. And then we can just solve for alpha. Well, now you know how to do it. I think this question, I said this before, but Revision Village's hard questions are a little unreasonable in terms of their difficulty. I don't think you're gonna see this difficult of a question, but I wouldn't put it past them. I have seen questions that are almost as difficult as this on an actual paper, but I don't know. I feel like they needed to give a reminder that, like, the leash can't go through the fence or something. This is definitely a smart people question. Anyway, solve for alpha. I'm not gonna solve for alpha. I spent way too long on this question. But you know, this is HL, so anything goes. Okay, let's see. I have my function f, which is e to the power of x times cosine x. Then, by finding a suitable number of derivatives of f, determine the Maclaurin series as far as x to the power 4. Why? Why would they make you do this? I don't know what they're trying to make you do, because in your formula book, they give you the Maclaurin series for both cosine and e to the x, so you don't need to find any derivatives. And I'm going to do it that way. Screw these guys. I don't think that's a real HL question, because they wouldn't tell you to do something in a specific manner when you can just look at your formula booklet. So, IB, Math, AA, formula booklet. So see, we have the Maclaurin series of E, and we also have the Maclaurin series of cosine. So I don't know why I need to find those derivatives. So E is 1 plus x over 2. It's the same as every other grade boundary. Oh no, I didn't take your test home. So I guess that means I'm gonna have to come early tomorrow morning so I can get them marked before the first block. Depends on the linear algebra. I can do some. I'm a little rusty, but I can do like basic stuff, I guess. Like what do you need help on? It's around 80% for a 7, I want to say. Like 78%? So yeah, Barbara, it doesn't hurt to ask. You can feel free to type a question in the chat, and I can try my best. Stuff with matrix bases and dimension. Possibly. Like, are you trying to find a basis or finding out how many dimensions a matrix has? Do you have a particular example? Weird, I can't change my page. Ooh. I guess if you can copy paste it, sure, but then you might need to reformat it once it goes into the chat box. Like normally I do like matrices by rows. So for example, This is a 3 by 3 matrix. 1, 0, 1 is the first row, then a 2, 3, 2 is the second row, and then 5, 6, 7 is the third row. Hopefully your matrix isn't giant so that this isn't too hard to reformat. But anyways, while Barbara's doing that, here's all the terms of each Maclaurin series that goes up to x to the power 4. And then if we multiply them together, then the Maclaurin series is just the multiplication of these two Maclaurin series. Honestly, I feel like this is a longer way than doing it their way. Probably should have done it their way. You know what? Forget it. I'm going to do it their way. Forget all of this. So a Maclaurin series is a Taylor series centered around A, but I'll get back to that in a bit, because now I have my first math help question. So 1, 2, minus 1, 3, 6, negative 3, 2, 7, 4. And then this is your matrix A, and then we need to find a basis. So you need to make sure that the vectors in your matrix are not linearly dependent. And then essentially 2 for a column. Which column? Oh, I see. Okay. So the transpose of this, right? Yeah. You know that oh man, I did this question like 4 months ago, and I've already roughly, oh, and there's 4 matrices. 3, 9, 6, 2, 7, 4. Okay. So at most, this matrix is gonna have just 3 vectors as a basis, because one of these is linearly dependent on some combination of the others. Oh man, but let me see if I can remember how to do this. And I'm gonna warn you, I probably don't, because it's been a while. And I have my notes from my linear course that I just took, because I'm in the middle of doing my master's and I just finished a linear algebra course, but it's on my other account on my computer. So, oh boy. Because all I need is a refresher, but unfortunately I don't even know if I can pull out a refresher right now. Let me see if it's on my phone. Otherwise, we're gonna have to do a Google search together. Alright, time for a little side quest. So let's see how we can find the basis of a matrix. And then, I don't know, let's see if this is good. Okay, you gotta reduce it. And then you can observe the row space, which means that you can find some expression, find out which ones are linear dependent, and then whichever matrices span the row space or the vector space or the column space are going to be your basis. And then I don't think you need to know rank and null space just yet. Okay, so what we can do is we can try to reduce this as much as possible. So let's just put this into a matrix reducer. So this has 3 rows, 4 columns. Unless you've already done this, then feel free to type it in the chat. But so 1, 3, 3, 2, 2, 6, 9, 7, -1, -3, 6, and 4. So we have this as my reduced matrix. I just Googled it. There's lots of matrix reducers online. But I guess I can send it if you really want this specific one. Okay, and then let's see. So now we have this reduced matrix, and then their row spaces are identical, and then row operations preserve stuff. I don't know if you know that much about it. And then let's see. So we can see that row 3 is 0. So let's see. They are also linearly dependent, blah, blah, blah. We can test this. This gives us C1, C2 are 0. Because they're independent since they span this row. Blah, blah, blah. Okay, let me just read this real quick, because okay, here it is. Let me zoom in. It's all coming back to me, and I'm not just lying. So essentially, to find a basis, they said it right here. The usual procedure for solving a homogeneous system, A times a vector x equals 0, also results in the basis. Well, for the null space at least. So essentially, what we needed to do was solve ax equals 0, which is equivalent to solving ux equals 0. So essentially this gets multiplied by an x1, x2, x3, x4. and then this needs to equal the 0 vector. So what we have is we have, you know, 4 sets of equations. X1 plus 3x2 needs to equal to 0. That's the x vector multiplied by the top row. X3 needs to equal to 0, and then x4 needs to equal to 0. So, in other words, what does this say? The first equation here implies that, well, x1 is some sort of multiple of x2. So your x vector can be represented as this: x1, x2, x3, x4, but we can say that x1 is -3 of x2, and then the rest stay the same. Oh my gosh, this is so embarrassing. I did this literally like 4 months ago. Okay, let's see. This is technically zeros. So we can treat x2 as a parameter . T. So this might be your basis, but again, man, it's only a one-dimensional basis. I feel like it should have at least 3, or maybe... But, hey Bobbert, did your professor or teacher tell you how to find bases? Maybe I should have asked you that first, so that we could have followed their procedure instead of this one that I found online. Haven't really learned it yet. Okay. You know what? Finding bases is a solved algorithm. So I just literally Googled basis. And then basis is very generalized, like basis of column space, basis of null space, basis of row space. But I'm going to assume they want the column space. But let's try this. just as find basis. Okay. So what I'm doing is finding, I think, the null basis, which is a basis. It's not the basis. I don't think there is a basis. And then do you have like an answer or anything? Answer key to check? I don't, unfortunately. Okay. Because what this is saying here is once you've reduced this to some sort of echelon form, then any leading ones represent wherever you have leading ones, this column, the original vectors in those columns form your basis. So your basis of your column space is the first vector, the third vector, and this vector right here, the fourth vector. Because, okay, let me see if I can reason out what we're doing. Like ones that have pivots. The basis is a set of vectors, and then, for example, the basis of the column space. The column space is the space that all the vectors span. So for example, these are my columns, right? And then this is just a two-dimensional space. So they span the entire R2. And if they were not independent, then they won't necessarily span R2. For example, obviously 2, 1 and 1, 0 are whatchamacallit, linearly dependent. So the only thing they span is the line 2, 0 or 1, 0, vector 1, 0. Whereas if they were linearly independent, this implies that you can add any multiple of these two vectors together and, you know, they create vectors. And then because x1 and x2 are arbitrary, their vector sum basically is any direction on the plane, so it spans all of R2. But you can see that that's not the case for the second example I did. Something like this. That just makes multiples of 1, 0. So this is the basis of the column space. So what row reducing does is it shows you which, I guess in a nutshell, which column vectors are independent. Because again, if we're trying to solve this, or not solve it, but if I multiply this by a vector x, that's the same as multiplying this one by a vector x. And if you do your matrix multiplication, this ends up being the first column vector times x1 plus the second column vector x2 plus the third and the fourth. And you can see that this one is just a multiple of this one. We can combine these two together and just say that, you know, x1 is going to be some other number. So we don't need this one. So the first vector, the third vector, column vector, and the fourth column vector are the basis of this particular matrix. So that's why you can go back and say with the original numbers what the basis are. You can also say that these are the basis. That's totally fine. There's bases, basises, whatever the plural is. They're not unique. So you can say that this is the base, these three vectors. You could also say that the reduced column vectors are the basis, but these are clearly linearly independent. So hopefully that answers your question, Bobbert. Yeah, no worries. I'm sorry I couldn't help you out more, but like I said, it's been 4 months since I took the course, and I just forget everything about it and move on to my next course. All right, back to this one. Okay, the definition of a Maclaurin series is that this is a Taylor series centered around 0. And I forget the Taylor series notation, but it's like T of X. And then I think the bottom number is where you're centered, and then this is what degree you want. These two numbers might be switched. They might just be written completely different. So this is your function at 0 plus the derivative of your function at 0 times x. Second derivative of your function at x squared over 2. Third derivative at 3 factorial and because they want specifically up to x to the power 4, fourth derivative at x to the power 4. 4 factorial. Alrighty, so we need to find first, second, third, and fourth derivatives. So first derivative is going to be, oh man, you got to use a bunch of product rules. Why do they do this? So this is e to the x cosine x minus e to the x sine x. Okay. And then second derivative wait a minute, this is a calculator question. Oh my gosh, what am I doing? Can a calculator do multiple derivatives? I don't think so. Okay. I'm gonna have to keep doing this the long way. So, e to the cosine of x minus e x sine x. So that's the derivative of the first term, and then the derivative of the second term, which is e to the x cosine x. Okay, it's not as bad as I thought it would be. Plus e to the x sine x. So luckily, things cancel. Here and here. So we get 2e to the x sine x. And then I need to find the third derivative. So that is -2. And then the derivative ex sine x, which I just found out earlier. Okay. And then I don't need to calculate the fourth derivative because a calculator can calculate and evaluate one derivative at a time. So if I know what the third derivative's function is, the calculator can do the rest. Okay, so let's see. Let's take some inventory. I need f of 0. So that's just 1. If I plug in 1 into this. F prime at 0 is, I plug in 0 into here. So this is 1, and then this is 0, so that's still 1. The second one is here, so this is just going to become 0. The third one, this is 0, this is 1, and then 1 times -2 is -2. And then I can calculate the derivative, the fourth derivative. So I'm going to take the derivative of all of this stuff. So e to the x cosine x plus e to the x sine x. Okay, I need another bracket. And then evaluate at x equals 0. Why is this such a weird number? Okay, I'm cheating again. Just Ron, thanks. Okay, let's say that we have our function f, which is e to the power of x cosine x. Okay, and then g, I'm gonna call f prime. And then I don't necessarily need the graphs. Decimals can do derivatives for me. H is the derivative of g. Actually, can I write it like this? Double prime. Yeah. J of x is triple prime. And then J, H, I, J, K. 1, 2, 3, 4. Wow. See, look at how efficient this is. Okay, so whatever. I don't even need to call these names. So f at 0 is 1. And then let's find out f prime at 0. That's also 1. F double prime at 0 is 0. So far so good. F triple prime at 0 is -2. And then quadruple prime is -4. So I don't know where the graphing calculator went wrong. But okay, we're done, basically. So the Maclaurin series is 1 plus x plus, well, following the formula, this one's 0, this one is going to be -2x squared over 3 -4x to the power of 4 over 4. Right, there you go. Sure, you can simplify this a tiny bit. I guess I should. So this is just going to become 3 because the 2 in the factorial will cancel out, and then we can write this minus right here. This minus can go right here, and we can write this as 3 factorial. Sure. Okay, and then hence or otherwise determine the value of this limit. Okay, so what we can do is we can do a substitution of this part using our Maclaurin series right here. So this is going to become, and then this has obviously more terms, but those won't matter, as you'll see shortly. Okay, and this is neat. This is kind of a precursor to big O notation, although it's not quite big O notation for those that know what I'm talking about, which is probably none of you guys. But like I said, I'm going to do a substitution. and replace the ex cosine x with its Maclaurin series representation. So let's look at what happens. The 1 and the x cancel out with this 1 and the x. And then look at what you have left over. You have a bunch of x cubed terms or higher. And then when you divide by x cubed, well, each one of these terms can divide by x cubed. So what are you left with? You're left with negative 1/3 minus x over 3 factorial plus the rest. And then these have higher powers of x. And now it's totally appropriate to evaluate the limit because there's no issue with plugging in 0. That just means that all of t, that terms with x, go away. So this is kind of, like I said, big O notation. So what's the limit? The limit is negative 1/3. Yeah. Whew. All right. And then now it's onto the actual difficult questions, and they're the long ones. So let's see. This will take 13 minutes. This will take 14, 20. Okay, this overall will take like over an hour. So I'm gonna say I'm gonna do this one, and then maybe I'll call it there, because then that's about a 2-hour stream. Slow day today. Okay, let's see. We have these coordinates, and then I need to find OA cross OB. So that's easy enough to do because you just cross these two vectors. OA and OB are whatever they're called, location vectors. So you just put this into your vector product formula. This one. Now, obviously, I'm not going to do that because computers can do that. Cross product calculator. So I'm going to put 104 and then 223. 104, 223. So there you go, -8, -5, and 2. And then determine the area of triangle OAB, giving your answer correct to 2 decimal places. So essentially you have this triangle from O to A to B. And we want to find this area. So we're going to essentially use the area of a triangle. We need to know the length of OA. I guess I should call it OA. We should try to find the length of OB. Hi, Just Ron. And if I can find the angle in between, then I can just use the formula for an area of a triangle. So we need to find the area in between them. Slight panic mode? Well, hopefully I should be able to help you. What's it about? Complex variables. Like complex numbers or just complex variables in general? Well, either way, if it's basic stuff, like if you're an HL student, like an IB student, then I can definitely help you out. Do you have like a particular question, or are you just confused about any concepts of complex variables? Basically, I need to prove that this is that. Yep. And then what do you know about complex numbers? Because we can do this the long way or the not so long way. And I'm assuming that star means times, right? Okay, so let's do this the long way. I'm assuming that you don't know polar coordinates yet, or Euler's form. So let's say, oh, you do know them. Okay. So let me show you. It would be easier to show them because if you understand how complex multiplication works, then, you know, this is pretty straightforward. So let's say that x, right? Or z. And then let's write this in whatever form, Euler form. We know that this is the absolute value, or the magnitude of z, times e to the power of I theta, which is the argument. And then let's say that w is, of course, by definition, the magnitude of w times e to the power of the argument of theta. And then generally, if we need a second variable for an angle, we use phi or phi. And then let's just multiply the left side and the right side, right? So z times w is, by definition, multiplying these sides right here. So that's absolute value of z, e to the I theta, times absolute value of w, e to the I phi. And what we're going to try to do is we're going to try to rewrite this as a single Euler form. So this is absolute value of z times absolute value of w. And then we can use exponent rules and then add our exponents together for e. And then hopefully you can see where I'm going. The absolute value of z times the absolute value of w is, well, we can just keep them that way. We can factor out the I. And then you're basically done, right? This is the Euler form of z times w. The coefficient here, whatever it is the magnitude of zw. And, well, this has to be this. And then also the argument of their product is just adding their arguments together. So that's a way you can show it if you want to use Euler form. And this is the easiest way to show it. So hopefully that makes sense. If you wanted to use a Cartesian form, it's a pain in the butt. But it's possible. It's just you kind of need to do a lot of stuff. Why does this show it? Because the Euler form of ZW, right, is by definition whatever the magnitude of ZW is times E times, I guess I'm just going to call it the arc of ZW. So essentially you're just equating the two. If I multiply the right sides, I get this. The Euler form of Z times W is literally this. So if you just compare the two, then that means that these two have to be the same. Yeah. If you want to do this Cartesian way, oh man. So let's say that you have x plus iy. So the length of z, right, is the square root of x squared plus y squared. This is just Pythagoras. Yeah, Cartesian is not fun, but we can do it too. It's fine. W, let's say, is a plus ib. So the magnitude of W is a squared plus b squared. All right. Then Z times W is going to be x plus iy times a plus ib. And then we can, you know, FOIL this out, expand it out. So what do you get? You get, oh gosh, a times x minus b times y plus I of a times y plus b times x, something like this, right? Here we go. And then if you were to do Pythagoras on this thingy, then this is the length of ZW. As long as I actually multiply this properly. And then if you multiply these two together and then simplify this one, they end up being equal. So yeah, not fun. Way easier to do this in polar form. Or not polar form, Euler form. Polar form works just as well, but you do need to do a little bit of expanding. So hopefully that answers your question. Just Ron. Yeah, no worries. Okay, so let's continue. I also need to find this angle in between vector OA and OB. And if you check your formula book, right, we know that, well, there's two ways we can do it. We can use the scalar product to find theta, or we can use the vector product to find theta. And because we already did the cross, maybe we want to do the cross. I'm not sure yet. I'm gonna do this one. So to do that, I need to find the magnitude of OA and OB, which is great because I needed to find it anyways for other reasons. So what is this? This is the root of 17. This one is 4 plus 4 plus 9, which is 8 plus 9, which is 16, which ends up being 4. So I know that this is root 17. I know that OB is 4. And then OA dot OB is 2 times 12, which is 14. So in other words, 14 is 4 root 17 times cosine theta. So then theta is the inverse cosine of 14 over 4 root 17. Whatever the heck this is. I guess I'll figure it out. Okay, mode. Make sure I'm in radians. So inverse cosine 14 divided by 4 and then root 17. So 557. Oh boy, okay, almost done. So then the area is 1/2 times root 17 times 4 times sine whatever. Oh shoot, there was such a better way to do this then. I'm so dumb. Okay. Okay, we can do it this way. I should have realized sooner. Gosh. Like I said, I got a late night debuff right now. You're supposed to notice that this thing is this thing. And then the area for a triangle in between that would just be divided by 2. So all I needed to do was find the length of this and then divide it by 2 instead of doing all of this extra work. Oh well. So let's see, the length of this thing is 64 plus 4, which is 68, plus 25, which is 93. So the area is root 93 over 2. Of course they want a decimal, so so 4.8, 2. Okay, and then we need to find the Cartesian equation of the plane OAB. So this makes a plane, and my Cartesian equations are always so rusty, but it looks like this. So I'm going to cheat. Oh boy, yeah. I need a refresher on this, but our vector product is the normal of our plane. And then, basically, the equation of the plane is the normal dotted with some generic vector. And then this needs to be equal to the normal dotted with a location vector on the plane, which is just like OB. Okay, so this is 0 because these two are perpendicular to each other, and then over here that's just whatever this stuff is. And here you go. Here's the equation. Okay, and then let's see. Find the vector equation of line 1 containing the points A and B. Oh. Really? That's it? Okay, so now we need to find this vector. And that's easy enough to do, right? We need to find the direction vector BA. So 2 minus 1 is 1, 2 minus 0 is 2, and then 3 minus 4 is negative 1. So the equation of our line is some point on the line as the location vector. So it doesn't matter what we use, I'm going to use A. Plus the direction vector times some parameter. So this is line 1. And then line 2 has this one. Copy. And then let's see, determine whether these are parallel, skew, or intersecting. And then if they are intersecting, where do they intersect? So essentially, we need to equate these and then see if there's a solution to the system. So line 1 equals line 2. So that's line 1. This is equal to 0, 12, negative 9, plus this. Okay, and then I forget how they tell you to how to solve this, because I don't want to do it the wrong way. Okay, well, first off, these are not parallel, so they either intersect or they're skew. which is what this is saying. And then let's subtract this vector from this one. So what do we get? Or honestly, these ones are bigger numbers. I'm gonna subtract this one from that one. Okay, and then we can solve this system. The system says that t is equal to -1 minus 3s. 2t's is equal to 12 plus s. And that negative t is equal to -13 minus 4t. Okay, and then I'm going to use these two equations to solve the system. I'm going to add them together. So I get 0 is equal to -14 minus 7t, which implies that t is -2. This implies that s, we can go back and then plug it in somewhere. So let's do the second one that I haven't used. If t is -2, then this is -4. So then s is -16. Okay, so then these are the parameters for our line, and then we can plug them back into each line equation and then find out the coordinate and see if they're the same. Because if the coordinates are the same, then they intersect or they skew. So t is -2, s is -16. Okay, so let's see. 1 minus 2 is -1. 0 minus 4 is -4. 4 plus 2 is 6. And then over here, we do not have, this is definitely not 1. So I don't even need to check the rest. So there's skew. Oh, apparently they intersect, so I did everything wrong. Okay, I got my t right. No, I didn't. Oh, wait, hold on. Oh my gosh. Cancel everything. Hold on. I messed up because I wrote the equations wrong. This was supposed to be s, so then this is s. So then t, this is -2, so that's 6, so then t is 5. Okay. So this changes everything. Great. So 1 plus 5 is 6, 0 plus 10 is 10, 4 minus 5 is -1, and then likewise over here, you get 6, 10, and also -1. So these intersect. My bad. It's all because I put t here, and that should have been s. Okay, so I'm not going to continue the other questions. but I am going to check my answers for everything I've done so far. And then I guess I'll continue on Sunday. Okay, 100 degrees. 100 degrees, nice. .92 seconds. 3.92 seconds. 1.37, 1.37, 15.4, 15.4. Okay, 64 years old. 63. Okay. My years are a little off. Probably some rounding errors. Good enough. Okay, 240, 39.5. Hey RGPT, you just came in like right at the end of this. 241, 39.5, 39.5, 241. I'm off a little bit. How are you though? Oh man, this guy came in asking me to find a basis for a matrix. Oh, that sucks. And then I just took a refresher linear algebra course like 4 months ago, and I like completely blanked out. And then I had to Google it. But then it came back to me. But when they ask for basis, do they imply column, the basis of the column space? Okay, I checked this one after I finished it because I was curious. Yeah. Yeah, that's what I was wondering. Because, like, was it the basis of the null space? The basis of the column space? Because that makes more sense, right? And I asked him, and then he just said, oh, they just wanted to find a basis. Yeah, whatever. I found the column space and the column space basis and the null space basis anyways. But that was a fun review. Anyways, 1.5, negative 2.6, 13.1, 14.6, 8 points, 8 points, easy peasy. Oh man, this question. I didn't even bother figuring it out. So I'm not going to check it. I cheated for that one. And then this one right here, 1/3, negative 1/3. Calling stuff null space, column space, row space is confusing. What do you call them? Yeah, domain range kernel. I thought there's a slight nuance between, like for example, a null space and a kernel. Like there's a slightly subtle difference, right? Something to do with something. I swear this was pointed out to me. Like null space is, you know, the independent vectors, blah blah blah, for the solution where it equals 0 or something, and then the kernel is slightly something else. I know that you can treat them more or less as the same thing, and I would. Okay, I'm gonna check this. It's on my other account. I swear to God, there is like a very slight difference. Because I have my linear algebra textbook as a PDF on my other account on my computer, so I can't check it right now. But I swear there's like an extremely minute difference that actually isn't that big of a deal, and you can just use it interchangeably. But I might just be going crazy. Anyway, so I got this one right, and you missed this one, RGPT. This one's kind of fun. It was like a pseudo big O notation question, which is, that's nice for a high school class. And then this one I kind of check through, so then I know it's more or less right, with some mistakes here and there. But overall, like I said, I was tired today. Also have a late night debuff, as a streamer that I watch says pretty often. But yeah, no jazz. Really only two people asked for help this whole time. Yeah, that sounds like burnout. Are you allowed to take a break? Well, why shouldn't you? Because there's a time crunch. You should think about your mental health. So it's good that you're taking a break. Nah, screw time crunches. So arbitrary. Like, go look at, like, especially in math, so arbitrary. People spend their whole lives trying to figure out, like, a millennial puzzle, and they can't even do it. What about Fermat's last theorem? Wasn't that, like, some X amount of years that it took him? Yeah, I know grad school's about time crunches, but that's so stupid. That goes against, math, I think. Personally. Yeah, not for Matt. Someone proved it. And then wasn't it like a 500-page proof or something? Yeah, right? Like, that's why this time crunch is so lame. Because, good math takes long times to prove. And, like, great mathematicians spend a long time. Yeah, I know. There's other reasons why there's a time crunch. But that sucks, right? That's what I tell my kids. Yeah, but you need background, which is the problem. And background gets deeper and deeper. Yep. Like, I don't know if I'm considered a radical teacher, but, like, I don't necessarily care when you write a quiz, or even if you re-quizzed later, like almost like towards the end of the year. If you showed improvement, then shouldn't that be what your grade is? Who cares what you did in the past? And who cares how long it took? Yeah, but it's such an old school way of thinking, right? Like, oh, you messed up before, so then you're gonna get penalized now. Yeah, and how long it takes shouldn't be a big deal. Honestly, you know, I give my classes as long as it takes. So some people, obviously they have other classes, but let's say they have like a free block or something after the class that the test takes, they're welcome to stay. They can have as much time as they want. I think, like I said, how long it takes is such a arbitrary measure. Very old school, impractical, definitely. There's people complaining about it not being fair. Well, if you offer it to everyone, then it is fair. It's not how is it anyone's fault that your kid didn't take that opportunity, you know? Like, I make it very clear that this is available for everyone. They don't have time blocks open? Well, then come in at lunch. Come in early before school. Come in after school. I don't care. The kids know this. They can tell me, and then I'll come early or stay late. Or have my door open during lunch. Is this radical? I feel like this is radical for old school people. Parents will complain. Why are you making kids stay up? Well, they don't have to. It's an option, right? And generally, okay, I think you're looking at it like parents in the worst way. Because I think as long as you explain that everything you're doing is for the sake of them being better, then they're generally on your side. Yeah, I know there's, yeah, there's the Karens, but you know what? Screw the Karens. And, you know, if you have a competent employer, then they're going to be the ones protecting you from the Karens. Oh my gosh, don't even mention it ruining everyone. So, you know, global pandemic, right? So in my city, the start of this school year, we decided, okay, we are going to have everyone come back. Let me draw out the schedule. So the year is going to be split up into not semestered, but quarters. And each quarter is 10 weeks at a time. And then within those 10 weeks, a student is enrolled in 2 courses. So they do 2 courses, they finish it, and then they move on to the next 2 courses. So, you know, you get your eventual 8 courses, which is a full-time load for a student. And then essentially, to avoid congestion, right, and prevent the spread, you have one of your classes. So again, as a teacher, I only teach 2 courses per quarter. One class is going to be split up into 2 parts. So it's split up in half. There's an AM block, and then there's free time. Well, not free time, it's called flex time for extra things. And then there's a PM block. So this is class 1. Class 2 is online. And then within a quarter, every week you alternate which class is in person and which class is online. So hopefully the system makes sense. And then this repeats through the quarters. And then flex time is used for you to plan your online lessons. And for any sort of linear courses, like for example, IB, they're short on hours if they're in a quarter system. So they have little flex blocks throughout the year. So some Karens complained that their kids were not getting enough teaching hours in the system. And so for the last 2 quarters of the year, we just started quarter 3, you know, they've made such a big hubbub that the school board has said that we now have to, for the online classes, bring them in during flex time and give them in-person instruction. So it's just extra work for no reason. Ridiculous. My school's not happy with it. My students are not happy with it. Flex time is not necessarily lunchtime. The AM class is from 8:40 to 10. basically 10:20. Lunchtime is at 1 is lunch is at 11:30. So you have an hour of flex lunchtime, and then you have another hour of flex. But yeah, that was like just, time for us to get ready for online, to teach linear courses. And then all of a sudden, yeah, parents were complaining, the rich, affluent parents. Well, no, like once they finish a class, right? Then they go home. It's not necessarily a free block, right? You go to your class, and then your other class is online, so then you go home and do it at home. So flexes are specifically for, for example, IB students. And then we teach them in person. Can you study for bio? Can I study for bio in my class? Sure. Yeah, so then they want to shove the online kids into the flex time, which ruins this entire schedule. Don't say that. Long-ish. Longish lesson. Yeah, it was a crazy. It was ridiculous. They went to the news, and then obviously the news just like ruins teachers' reputations. And then yeah, they're like, "Oh, my kid isn't learning enough, and we're worried about their grades." And then they interviewed like they only showed like two kids, because obviously they didn't show all the ones that said that it's a bad idea. And two kids were like, "Yeah, I'm not learning enough, and I'm worried that I can't get into my university." And then now the entire city has to bend to the will of a few Karens. Well, the entire school board in my city. Yeah, so that's the most recent story I have about Karens. Yeah, that's what I feel, right? It's like your kid does have instructions, and they're supposed to do stuff at home. And I don't know, you're the one that's supposed to be telling them to keep up with the online work. Yeah, it's never about education. Like, come on, we're in a global pandemic, and you want to. And my specific Ministry of Education, our government, has said that this year's priority for school is not educating the kids and getting curriculum in, and the parents are complaining about it, and it's ridiculous, so ridiculous. Like most of these parents, like the most recent experience that they have with school is when they were in high school, which is like God knows how long ago, like 20 years ago. They have no idea how different it is. Yeah, luckily most parents are pretty good, at least where I'm from. Yeah, the school board just caved in immediately. Like 2 days after that news article came out, they were just like, "Hey, we're changing things." Yeah, squeaky wheel gets the grease, as they say. The loud minority. Man, and sometimes I just wish that like my professionalism wasn't on the line, and I would just like tell them off. No, not, they don't deserve death. Their kids definitely don't deserve death. It's just like, I wish I could just be like, "Oh, no worries, Ron. Hope you understood everything, though. And hopefully that's an acceptable answer that your teacher will accept." But just like sometimes I'm like, I just wish I could just be like, oh, F off. Like, you have no idea what it's like, and your opinion isn't valid because you don't know anything. Well, you could be a world leader like the Philippines Duerte. Just screw you, it's my way, or else you die. Yeah, but you also hate dumb people. And high school's full of dumb kids, so you would hate yourself. How I deal with it? I don't know. You just gotta go with the flow. I don't know if you can tell, but I have a very chill personality, so I can, for better or worse, handle this stuff. Because at the end of the day, I just don't care enough. Like, they tell me to do something, I guess I just have to do it now. Whatever. And like, how can I complain about extra work when I'm making extra work for myself, Twitch streaming math on my own free time? Well, I'm not saying that I don't care about teaching, but like, changes happen all the time. And if you're going to get upset with all these changes because of parents or the government or the news, then you're going to get very tired in this profession quickly. Yeah. Just, like, it's odd. I think that some teachers, like, teachers are heavily underrated in society, but at the same time, I think that some teachers have a huge ego. And you gotta realize, like, you're just a friggin' teacher. Like, you're not that important. Like, you individually. The profession is very important. But you as an individual teacher, it's not important. And then I told my kids today, like, if I died, then what happens? I get an assembly, maybe they cancel school for a day, and then immediately, after the weekend, they're gonna find a replacement for me. So why do I feel the need to be like this fighter and fight against all these changes? Yeah, too much bureaucracy. Oh my gosh. If I die, no one would care either. I would care. But yeah. Yeah, you see what I mean, right? Yeah, there's incredible teachers. Definitely. And they deserve credit. But at the same time, if they think like they're the end all be all, and it's about the ego, right? It's not about their value, it's about their ego. I just don't think like you're as important as you think you are. As amazing as you are. And yes, you can save lives, like literally save lives. But meh, you're replaceable. Yeah, and then if you're in North America, then being a teacher is quite easy. So the bar is pretty low. Damn, that's smart. Avoid being drafted in the Vietnam War so you become a teacher. Yeah, the bar is quite low. I'm not gonna lie. And like this is coming from you know, Canadian from Canada. Like both me and RGBT are from Canada, and like the States is even worse. Their standards are super low. You had to mark teachers like on their math or on their teaching ability. On their math, yeah. Are they elementary school teachers or high school math teachers? I'm gonna tell you right now, elementary school teachers do not have math skill, period. They are not trained to have math skill. High school math teachers, at least where I'm from, you need a degree in math, so you need to be semi decent. You don't need a degree in math? Wow. Alberta, what are you doing? Yeah, for high school, when you get your education degree, you need to have at least a minor in the subject in your teachable. Math ed degree? Hmm. Yeah, that sounds like my master's program that I'm doing right now. Yeah, bar is low. And the pool of math teachers is small too. So that makes it even worse. So you don't even get to have a good selection. And what you do get is pretty crappy. Yeah, I know. Like my master's program is specifically for math teachers. So it's not I don't want to call it a math master's cuz it's not. Like it's just essentially yeah, honors first year, second year courses and it's just to make you better at math. Yeah, it's tough. Like I by no means think that I'm personally an amazing math teacher. You know, I don't do anything groundbreaking, no cutting edge like pedagogical teaching practices and stuff, but like still, even in comparison to other math teachers, I'm pretty good. Not gonna lie. Yeah, but you know, we don't get to decide what we have to teach. Some person that probably doesn't even teach math decides what the curriculum's gonna be. Oh, why is there statistical analysis? Because it's biology. What else? What other math can you do besides statistics? Some person who doesn't even know the quadratic formula. Yeah, There shouldn't be any math? No. Math is everywhere. Get used to it. You will never escape numbers in your life. Period. Oh, but speaking of trying to be cutting edge in teaching skills, I bought this book from a guy named Peter Lidgell, who has been doing research in math education. But if you really care about teaching, you should check it out. Let me go grab it. Yeah, I don't know where Max is. It's called Building Thinking Classrooms. So I'm reading through it. It's actually pretty interesting. And it's very radical, I would say, compared to a traditional classroom. But it's definitely something I'm interested in trying to implement. Yeah. All the way from K to grade 12. How to create critical thinkers, essentially. Yeah, I know you don't have time, RGBT. Have you... I think a while ago I asked you to also check out this rant from some mathematician. And then it was called A Mathematician's Lament. That's pretty good. It's a short read. And it'll just make you feel sad because it complains about the state of math education. Yeah, it's a quick read. But if you want to feel worse about the state of math education, give it a read. Oh yeah, I'm sure everyone in math feels this way. I feel this way, and I'm perpetuating it still. Because what else can I do, given my constraints? I have to fit all this curriculum in such a limited amount of time. Yep. And that's what I'm saying, right? I'm just some lowly math teacher. I have no ego. I can't change the ministry. Yeah. Except this complaint on Twitter. Or, well, Twitter too, but I mean Twitch. To some Albertan grad student who also complains about his life back to me. And society's too rigid, burn it down. Anarchy. Hunt down the billionaires. Redistribute wealth. Restructure society. But like I said, I can't do it alone. Okay, let's see. I did not finish. One, two, three questions. 13 plus 14, which is about 30, plus 20, which is about 50. So I got like 50 more minutes, an hour's worth of this exam. practice exam, which I guess I'll go through on Sunday. But I think I'm going to call it here because, well, I don't know, there's not much else to do besides go around in circles and complain about society and how math is taught. So for those that joined in, thanks for watching. I'll talk to you guys later on Sunday. Yeah, but you know, I know you don't have time, but it's a quick read. Mathematicians Lament, but I'm sure it's just preaching to the choir. Yeah, you take it easy too. Don't work yourself to death. Okay, good night everybody.